Today we're going to be looking at cubic equations, and cubic equations are another example of polynomials. Now remember, a polynomial is some equation that is made up of constant terms and terms that just contain x and positive powers of x. Okay, so this is an example of a polynomial. In a cubic, the thing that makes it a cubic is its highest power is a cube. So in general form, that is the fully expanded form, a cubic might look something like this guy. Okay, we've got four terms, an x cubed, a minus 2x squared, a minus x, and a 2. We don't have anything else weird going on. Like we don't have, 1 on x's or square root of x's or things like that. It's all just positive powers of x. And the thing that makes it cubic is the highest power is that 3. Now, just like quadratic equations, which were ones that look like this, just like quadratic equations could be written into a factorized form like this. Okay, we can also factorize cubics, so we can get it into a form that looks like this. Now, as far as we're going to be concerned, we're going to spend a little bit of time getting from general form into factorized form, but we're not going to spend heaps and heaps of time, and we're going to give you relatively easy cases of that. If you're in the specialist stream, you will need to eventually look at more complicated factorizations, but for our purposes, we're just going to go through a few processes of how to get into factorized form. Now, as with quadratics, factorized form is really good for finding x-intercepts. And that's what we're primarily going to use it for. We're going to use it to find the x-intercepts of the cubic. The y-intercept we can get by looking at the constant term in the general expansion. And as far as our sketching goes, that's all we're going to be wanting to look at. We're going to mark our x-intercepts and mark the y-intercept on. We're not going to worry about things like turning points. Turning points, to find turning points of cubics is much, much more difficult. We'll cover that when we do calculus. So you need calculus for that. We'll come back to this in semester 2. So once we've got those differential calculus skills, we can come back and we'll be able to actually find the turning points of these things relatively easily. But for the moment, we're just going to worry about the x-intercepts and the y-intercepts.